Hey guys, this is Project Sultan of Stats, and this is our Stat 199 final project presentation. And our project is titled Coffee Tasting: How to Make the Best Bean Water.
Yeah, so coffee is one of the world's most consumed beverages, with quality being a critical determinant of market value and consumer preference. So, despite the importance of quality, the factors that consistently yield higher quality beans remain underexplored. Our project is a comprehensive study of coffee quality across global producers who created 843 different coffees from 27 different countries. The main focus is on identifying the key drivers between overall coffee quality, with the research question being what factors are most strongly associated with the quality represented by weighted average score of a coffee. By investigating this question, we aim to help consumers quickly identify what characteristics of beans make the best coffee.
So for our coffee data, just some real quick things. We had 27 countries represented. We got it from the Corgus Dataset Project. It was created in 2022. And as far as what we did to the data, first we removed NANs, anything that had any NANs in it, we removed. And then we created a new variable called weighted mean score, where basically we took all of the variables where one was objectively worse and 10 was like a higher quality of coffee. And we used those to determine our new weighted mean score, which aims to look at what is actually the highest quality of coffee. Some variables like sweetness and bitterness, they were on a 1 to 10 scale, but it's not the same kind of objective 10 is the best, 1 is the worst, because some people like their coffee bitter, some like it sweet. So these were the variables that we chose, and we chose to have weighted mean score as our variable of interest.
So the distribution of weighted mean coffee scores is unimodal with a slight left skew. And the mean of the weighted mean scores is 7.789 with a median at 7.821. And the standard deviation is at 0.279. And there are outliers on both sides of the box plot with a minimum score of 6.478 and a maximum score of 8.762. And we also sorted our variables into three main categories, being location variables such as country, mean altitude, bag attributes like bag weight and number of bags for each batch, and of course the variety of coffee for each coffee in the data set.
So these were our results. Through our models, we found that none of the chosen variables were actually great predictors of coffee quality. However, we did find that the country of origin of the coffee was probably our most accurate predictor of coffee quality. And we had two interactive models, country and elevation, and then bag weight and number of bags. But we found that neither of those models really resulted in a more accurate kind of prediction of weighted mean score. But it seemed that the location variables that were to do with coffee production had maybe a little bit more bearing on the actual quality of coffee than the production method, whether that being the number of bags or the bag weight.
So if we look at our analysis, as we previously mentioned, none of our predictors explained a particularly large proportion of the variance or was strongly correlated with the weighted mean. So our best one was actually the interactive model using both location variables, but even that didn't get an R squared above 2.29. So comparatively speaking, the effect of adding the predictors with an interaction term didn't help that much. So, for example, with the location variables, over 20 predictors were added when we added the interaction term, but that only improved the R squared by around 0.05. And not all the observations from the original data set were incorporated. That's an important thing to note here, because around 100 of them did end up getting dropped when we filtered out for NANs and when we filtered out the outliers. So you do end up with a different data set being analyzed than what we originally had because of those drops. And we also made assumptions in the dependent variable regarding which attributes mattered most. We weighed taste more than everything else, and we didn't select every single component of the original total score. So it is our judgment being used for the dependent variable. And moreover, there's also no units for it.
Yeah, and real quick, we also only took out outliers that were not physically possible. Some of the elevations were way too high that don't exist on Earth, so that's why we took them out.
Yep.
Our main conclusion on coffee quality showed that the highest R squared value failed to explain most of the data's variance. A limitation is that there is uneven country representation and potential sampling biases. And for future direction, we recommend expanding the dataset with more diverse observations to gain deeper insights into coffee quality.